All right, we're going to split this notes packet into 2 days. Um, so let's talk about the value of r. So all of these polar functions are r equals. And the big question, our last big question for AP is the value of r increasing or decreasing? So again, you have polar equations that are r equals something. So um, it'll depend on what interval we're looking at. Sometimes r will change from increasing to decreasing. Remember, r is always equal to some sort of trig function, so those increase and decrease. The best way to determine the behavior of r, or the radius, is just to make a table. And you don't want to overthink it. We're not really talking about concavity. We're just saying, are those r values going up, or are the r values going down? So they may give you a small interval, so you may only have a few values to plug in, but that should be enough. So determine whether r is increasing or decreasing on each interval. So here's r. We're going to look at 3 different intervals. And let's just start by making a table and seeing what we get for values of r. So r is equal to 3 cosine of 3 theta. This is one of those rose curves with 3 petals. We begin by plugging in 0. So we get 3 times the cosine of 0, which is 3 times 1. And then what's between 0 and pi over 3? So let's plug in all of our common angles. So let's plug in pi over 6. That's 3 times the cosine of 3 pi over 6, which is pi over 2, because we're plugging into 3 theta. Cosine of pi over 2 is 0. So far r is decreasing. We've gone from 3 to 0. And then let's plug in pi over 4. 3 times the cosine of it's not pi over 4, it's 3 pi over 4. That'll make a difference. The cosine of 3 pi over 4 is negative 2 radical 2. What did I say? 2 radical 2? Negative radical 2 over 2. So r is still decreasing because you're going from positive 3 to 0 to a negative number. And then let's finish by plugging in pi over 3. Even though the endpoints aren't included, I still want to see what's happening at them. 3 times the cosine of 3 pi over 3, so pi, that's negative 3. Now, I don't know what decimal this is exactly, but radical 2 is 1 point something, and you're dividing it by 2. So this is like negative 3 times 0 point something, which is definitely a smaller number than negative 3. So negative 3 is further down the negative number line, so smaller than negative 3 radical 2 over 2. Okay, all of that is to say that r is decreasing on this interval. And showing the table should show enough work. All of these values are decreasing. And now we're going to look at the interval from pi over 3 to 2 pi over 3. So again, another small interval here. There's really only one nice common angle to plug in between. So let's take a look at this. Let's write down again what, starting at pi over 3, what we got for pi over 3. So we already did that math. That came out to negative 3. And then let's plug in pi over 2. So that's 3 cosine of 3 pi over 2. Cosine of 3 pi over 2 is 0. And then we'll finish with 2 pi over 3. So 2 pi over 3, we get 3 cosine of 3 times 2 pi over 3, so 2 pi. That's 3 times 1. All right, so let's take a look here what's happening. R is going from negative to 0. That's an increase. From 0 to 3, that's another increase. So R is increasing on this interval. And then finally, from 2 pi over 3 to 5 pi over 6. So you don't have to draw the common angles. I just like to see where they are. This is a good visual for my brain to work out what angles I can plug in here. So again, include the endpoint so that you have more than just 2 things to compare. So include 2 pi over 3, even though we just found it. That came out to 3. And then in between there could be 3 pi over 4. So now this gets a little bit, we have to think about this. This is cosine of times 3, so 9 pi over 4. Like, where does that fall? Remember, you can think about these as a mixed number. 9 pi over 4 is 2 and 1/4 pi. So that lands here at pi over 4. So This is 3 times positive radical 2 over 2. So we're going from 3 to something smaller than that, 3 radical 2 over 2. And then let's see about 5 pi over 6. Again, you're multiplying it by 3. So 3 times 5 pi over 6 is 5 pi over 2. So it doesn't really matter where 5 pi over 2 lands. It's either the top or the bottom of the circle. And in both of those positions, r is equal to 0. So 3 decreased to 3 radical 2 over 2, decreased to 0. So r is decreasing. And I want to give you a visual for what this means. What does it mean when r is increasing, r is decreasing? We've done a rose curve where we have a 3 theta. So let me pull one of those up. It's on one of our graphing worksheets. Let's see. Cosine 2 theta, sine 2 theta. Let me check our other one here. Here we go. It's got a different petal length, but here's a cosine 3 theta. So here's what we're saying here. Let me get some of these marks out of my way. So we had this rose curve, right? We were looking on the interval, what was it? It was 0 to pi over 3. So here's what the radius means. The radius is, where's the first point at 0? It was right here. So the radius is, what is the distance from the origin to that point, right? So that distance was 4. And then as this curve started tracing around, remember this was like the first path of the curve. So the r, the distance from the curve to the center, is getting smaller. You can see it goes from 4 to smaller than that, then to 0, right? So r is decreasing on the first interval, which was what our conclusion was. And then we said r was increasing. So from pi over 3 to 2 pi over 3, I'm going to switch back to the correct notes packet. There we go. From pi over 3 to 2 pi over 3, remember at pi over 3, we were here. And then back to 2 pi over 3. When we plugged in 2 pi over 3, we got to here. All right, so let's see what was happening there. Here we had an r that was negative, right? R was negative. So that, even though it seems like, oh, that's a really long value, but remember, it's negative. And then we start coming back around. Even though r is getting smaller, the value of r is increasing because those negative numbers are coming back to 0. And then r continues to increase because now on this interval, r is positive, and it's getting back to being a big positive number back up to 4. So r spans from -4 to 4 on that interval, or for us, it was -3 to 3. I think that looking at r makes sense when you're sort of on this first petal. It can get confusing when you're in the negatives. So I just wanted to give you that visual for what are we talking about when we say r is increasing or decreasing. All right, back to our notes. Determine whether the distance from the graph to the origin is increasing. So is the graph getting further from the origin? That's what increasing means. Or is the graph decreasing, which is getting closer to the origin? So that's kind of what I just modeled. So I want to sketch this picture again here. So let's take a look at what was happening. We said on this interval 0 to 3, remember that r is decreasing, right? So let's look at this interval here. It helps to look at a graph. So let's plot these points that we had. We had 0, 1, 2, 3. Oh, my pen stopped working, of course. So we had 0, 1, 2, face 0, go out 3. And then at pi over 6, we hit 0. So what's happening right there? This first part of the curve, r is what we just talked about. R is really long, it's 3. And then it starts decreasing. And what is the curve itself doing? It starts far away from the origin and it gets closer. So on 0 to pi over 6, the graph is getting closer to the origin, which is 0, 0. Okay, and then what happens? When we are at pi over 4, we're facing pi over 4, but we go negative. So let's say this is, I don't know, like -1.5 or something. Something right here-ish. And then when we get to pi over 3, we go 1 to -3. So here's the next section. what's happening to R there is what's happening to the graph there, because R is still decreasing, but the graph is getting further away from the origin there. So on pi over 6 to pi over 3, graph is getting further from 0, 0. So that's just me visually looking at that. We'll talk about what to do if you're not going to graph it, but that's just kind of interesting to notice. And what's different between these two values? Well, at 0 and pi over 6, R was decreasing, but also R is positive, or 0. And on pi over 6 to pi over 3, R is still decreasing, but R is negative. So that's something that's noteworthy. Okay, what about the next section from pi over 3 to 2 pi over 3? So let's graph these points here. So pi over 3, we already have that, facing negative 3. Then you come back to pi over 2, so you get back to 0. So what is the graph doing right now? It's getting closer to 0. So on pi over 3 to pi over 2, the graph is getting closer to 0, 0. Again, because I know that these trace counterclockwise, that's just from here to here, my graph is getting closer and closer until it hits 0, 0. And then what happens? When we face 2 pi over 3, we go forward 1, 2, 3 units. So now the graph is getting further from the origin. So on pi over 2 to 2 pi over 3. So on pi over 2 to 2 pi over 3, the graph, again, is getting further from 0, 0. And then let's look at the final section. So we have 2 pi over 3, and then we face 3 pi over 4, and we go out something smaller. So again, I don't know exactly what that's going to be. It's going to be like, I'm just going to go out maybe 1.5. Something right there. If I can get that plotted. And then at 5 pi over 6, we come back to 0. So the graph comes back and connects back to 0, right? So what's happening to the graph from 2 pi over 3 to 5 pi over 6? That whole time, the graph is returning to the origin, so it's getting closer to 0, 0. All right, so what was happening on the middle interval when we were getting closer? Well, the graph was getting closer. Here, R was increasing, and R was negative. And so when the graph is increasing but negative, I kind of consider those opposite signs. Like in my brain, increasing, I think positive, and then the actual values of R is negative. So if those kind of contradict each other, then the graph is getting closer. It's kind of like they're working against each other. You're getting closer to 0. But then on this interval, pi over 2 to 2 pi over 3, these values are positive. R is positive, and R is increasing. And so I think of those as matching up. Increasing, again, in my mind, is thinking positive. So because it's like a positive velocity or positive rate of change. So if those signs agree, then yeah, the graph is sort of accelerating and getting further from 0, 0. So that's what this distance to the origin is about. We don't want to have to sketch a graph every time. Sometimes we won't even have that choice. They'll just give us a table rather than an equation. So we can use a table of values. And what we're looking for is basically, do the signs match or not? So I'm going to put signs in quotes, because when I say signs of increasing and decreasing, I'm thinking like increasing is really a positive rate of change. Decreasing is really a negative rate of change. Think about slopes in that case. So if the signs match or not is what we're looking at. So the distance from the graph to the origin is increasing, meaning getting further. I always mess this up. Is it further or farther? I don't know. Getting further away. If R is positive and increasing, so positive and increasing, which means rate of change is increasing, is positive, I mean. Or if R is negative and rate of change is negative as well. So the graph is decreasing. So in this case, the signs match. then you're going to be driving away from the origin. You're accelerating. That's how I think about that. Distance from the graph to the origin is decreasing, basically if the signs are opposite. So if r is positive, but r is decreasing, or if r is negative, but the values of r are increasing, they're sort of working against each other. You're getting back to zero. Think about like putting the brakes on for a car. You're slowing down until you stop. All right, so let's look at this with the table. Now, I was given an equation, okay, but what if they just gave me r and they just generated these values for me? So I would need to be able to do this work, but this is just us practicing putting in some values as well. So fill in the table first, and then we're going to determine if the curve is getting closer to the origin, further from the origin, or neither. All right, so pi over 6. So this is 1 minus 2 times radical 3 over 2. 1 minus radical 3. So they do expect us to know that that's 1 point something. So this is a negative value. 1 minus 1 point something is negative. Then we put in pi over 2. 1 minus 2 times cosine of pi over 2 is 0. So that's 1. It's positive. 2 pi over 3. That's 1 minus 2 times the cosine of 2 pi over 3 is negative radical 3 over 2. So now we're at 1 plus radical 3, which is also positive and larger than 1. And then finally, we plug in pi. That gives us 1 minus 2 times negative 1. 1 plus 2 is 3, definitely larger than 1 plus radical 3. Okay, so if I want to determine if the polar curve is getting closer to the origin or further from the origin, then I need to look at two things. Is r increasing or decreasing? So these values show me that r is increasing overall, right? Okay, now what about at each different value? So it says determine when the polar curve is getting closer to the origin or further from it, or neither, when we're at any of these values. Okay, so let's look at these values. Let's see. At pi over 6, r of pi over 6 is less than 0. So r is increasing, but r of pi over 6 is negative. So those two are working against each other. So that means that the graph is getting closer to the origin 0, 0. And then what about the other values? So 2 pi over 3 they wanted. So r of 2 pi over 3. R of 2 pi over 3 was positive. It's greater than 0. And r is increasing on this whole interval. So because those two agree, that means that the graph is getting further from 0, 0. It's not slowing down. And finally, pi. So r of pi was equal to 3, which is, greater than 0. Don't need the equal 3 part. You can put that if you want, but it's the fact that it's greater than 0. So again, our signs agree here. And we're looking at, but you know what? Is the graph still increasing at 3? We need to look at one more thing. I should have had one more value in here. I would hope that they would give you values that you picked on either side of. Like, I don't know, does the graph start decreasing after this? So 1 minus 2 times the cosine of 4 pi over 3, because that's the next pi over 3 value after pi. That's 1 minus 2 times negative radical 3 over 2. So we're back to 1 plus radical 3. So actually, r of pi is equal to 3. And this is actually its max value. I know that 3 is the max value because you're never going to get, cosine has a maximum of 1 and a minimum of negative 1. So this is going to range from negative 3 to positive 3. So I know this is the max. I guess I didn't need to have the extra point, but this is the max value. So is the point at that maximum? Is it getting closer or further from the origin? Well, it's a turning point, right? So it's kind of hard to say whether that's really a max or whether that's really getting closer or further at that point. It's kind of like the turning around point. So this is where you would have neither. I'm not sure if we'll see neither on our AP test, but I just wanted to kind of put that out there. All right, we're going to stop there for today, and then we'll work on relative extrema and rate of change for tomorrow, last day of notes.